If I have y is equal to 2x squared plus x minus 3, I need to think of all the factors that I can get 2. Well, I can get 2 by multiplying 1 times 2, or negative 1 times negative 2. And then I have to think about all the factors of negative 3. I can get negative 3 by multiplying a negative 1 times 3, or a positive 1 times negative 3. So I'm going to need a pair of numbers in this column and a pair of numbers in this column when I multiply one of the numbers from the first column times one of the numbers in the second column, and then add that to the other number in the first column times the other number in the second column. We'll end up with our b term, which in this case is just 1. So let's try this. If I multiply 1 times negative 1, and I add that to 2 times 3, I'm going to get, well, 1 times negative 1 is just negative 1, and we add that to 2 times 3, which is 6, we'll get 5. 5 is not what we were looking for. We're looking for a positive 1. So what if I take 1 times 3? 1 times 3, and then we add that to 2 times negative 1. So 2 times negative 1. Well, 1 times 3 is 3, and we add that to 2 times negative 1, which is negative 2, and we'll get a positive 1. So that's what we were looking for. Here we're looking for a positive 1. So if we draw our factors, we have y is equal to, we have some numbers in parentheses and some other numbers in parentheses. We found that it's a 1 and a 2, both positive. So we'll have a 1x and a 2x, because 1x times 2x will get us our 2x squared. And then we have a negative 1 and a 3. But you have to be careful. You have to make sure you put the negative 1 and the 3 in the correct parentheses. We're multiplying the 3 times the 1. So if we're multiplying the 3 times the 1, here's our 1. So that means the 3 goes in the other set of parentheses. And if that's the 3, then this one would be the negative 1. So here's our factored form. We have a 1x minus 1 times 2x plus 3. Let's try this again. Here we have y is equal to 18x squared plus 16x minus 2. And again, we're trying to get this factored into two binomials, and we need to find all the factors of 18 and all the factors of negative 2. Well, there's lots of ways to get 18. We can get it by 1 and 18. We can get it by negative 1 and negative 18. We can also get it by 2 and 9, or a negative 2 and a negative 9. We can get it by 3 and 6, and then a negative 3 and a negative 6. So those are all of our factors of 18. And then to get negative 2, we can get negative 2 by multiplying 1 and negative 2, or negative 1 and 2. Those are the only ways that we can get negative 2. So now that we need two of these pairs that will multiply together and add to get us 16. Well, if we take 1 and multiply those together, we have 1 times 1, and an 18 and a negative 2. 1 times 1 is 1, and 18 times negative 2 is a negative 36, and we add those together, that's not anywhere close to 16. The pair that does work is if we multiply 9 times 2 and negative 1 times a positive 2. If we multiply those together and then add them, 9 times 2 is 18, and negative 1 times 2 is a minus 2. So if we add those, we'll get a 16, which is what we were looking for. So if we multiplied 2 and 9, that means one of these terms has a 2x in it, and one of these terms has a 9x in it. And if we multiplied the negative 1 and the 2, that means one of these is a negative 1 and one of these is a positive 2. But which is which? Well, here we multiplied a 9 times 2. So this 9 is multiplied by our 2. So if it's multiplied by our 2, then the 2 goes in the other parentheses. So this will be a plus 2. And that makes this one the minus 1. So here's our factored form of 18x squared plus 16x minus 2. Now we've been talking about factoring quadratics. Now let's talk about solving quadratics. If I was given the quadratic y is equal to 4x squared plus 4x plus 1, to solve this, we first factor it. So if we factor this, we have to think of all the numbers that will multiply together to get 4, and that's 1 and 4, negative 1 and negative 4, 2 and 2, and negative 2 and negative 2. And then all the ways we can get a positive 1 are just 1 or 1, and negative 1 and negative 1. And we need a combination of these pairs of numbers that will add together to get 4. I'm going to choose 2 and 2 and 1 and 1. If I multiply 2 times 1, and I add that to 2 times 1, well, 2 times 1 is 2, and we add that to 2 times 1, which is also 2, we get our 4, which is what we were looking for. So if we have a 2 and a 2, that means this is a 2x and this is a 2x. And if we multiply 2x times 2x, we sure will get 4x squared. And then we have a 1 and a 1, so this is plus 1 and plus 1. So here we have our factored form of our quadratic equation. So to solve this then, we need to find values of x that make y equal to 0. And to do that, we can set each one of these terms in our parentheses equal to 0. Because if one of them equals to 0, then it doesn't matter what the other one equals, because you're just multiplying that by 0. And anything multiplied by 0 is 0. So to do that, we set each of these equal to 0. So we have 2x plus 1 is equal to 0, and then we have another 2x plus 1 is equal to 0. If we solve this, we subtract the 1 from each side, and we get 2x is equal to negative 1. Divide by 2 on each side, and we'll get x is equal to negative 1/2. Now, our other binomial, or our other parentheses term, is exactly the same. So our solutions then are going to be x is equal to 1/2, and then x is equal to negative 1/2 again. So this is the solution for this quadratic. These solutions are called roots or zeros because these occur when our function or our y value is equal to 0. Remember, this is a graph of a parabola. So then these roots or solutions or zeros are just when the parabola crosses the x-axis, or when y is equal to 0. So that's how you solve quadratics, and let's try this again. We have y is equal to x squared minus 2x minus 15. Well, here we have a 1 here, and the only way to get 1x squared is to multiply a 1x times a 1x. So if we put that in parentheses, we just need to find our other two terms. So we need to find what numbers multiply together to get negative 15. Well, we can get it by negative 1 and a positive 15, a 1 and a negative 15, a positive 3 and a negative 5, and a negative 3 and a positive 5. Since our quadratic coefficient is 1, if we multiply any of these by 1 and then add them together, it doesn't change their value, so we can forget about that for now. And we just need to find two numbers here that multiply together to get 15, which we've already found, but then also add together to get a negative 2. And that's this pair right here. If we multiply negative 5 times 3, we get negative 15. And if we add them, negative 3 plus, or positive 3 plus negative 5 would be a negative 2. So what we have here is a plus 3 and a minus 5. So our factored equation then is y is equal to x plus 3 and x minus 5. But we're trying to solve this, so what we do is we set y equal to 0. And remember, if any one of these equals 0, then it doesn't matter what the other parentheses term equals, because it's just multiplied by 0. So that'll get you 0. So we set each one of these equal to 0 individually. So we'll have x plus 3 is equal to 0. And if we subtract 3 from both sides, we get x is equal to negative 3. And then we set our x minus 5 is equal to 0. If we add 5 to both sides, we get x is equal to 5. So our solutions then, or our zeros, or sometimes they're called roots, those solutions are x is equal to negative 3 or 5. And the last thing we're going to talk about are special patterns when we're factoring. Lots of times it's very difficult to find all the factors of one coefficient and all the factors of the other and then find the combination of the two sets. But if you ever see a quadratic that looks like a squared minus b squared, then you can factor that into an a minus b times a plus b. So for example, we have an x squared minus 9. The x squared is a perfect square, and the minus 9 is a perfect square also. So you could factor that into an x, and then a minus 3 and a plus 3. This works because if we take x minus 3 and x plus 3, and we do our FOIL method, we take our first terms, that would be an x squared. Then we take our outside terms. X times 3 is a positive 3x. Then we take our inside terms. We have a minus 3 times x, so that's minus 3x. And then we take our last terms. Negative 3 times 3 is a minus 9. Now if we add our like terms, this plus 3 and a minus 3, these will cancel. So we just end up with x squared minus 9. So if you ever see an x squared minus some number that you know is a perfect square, or if you take the square root of it, you'll get a integer or a whole number, then you can just factor that into this form. Now there's two more. If we have an a squared plus 2ab plus b squared, that always factors into an a plus b squared, or an a plus b times an a plus b. So if you have a 4x squared plus 20x plus 25, you can factor that into a 2x plus 5 squared, because this here is the same as 2x squared. And then this here is 25. That's just the square root of 25 is 5, or you can think of that as 5 squared. So if this is a 2x squared and a 5 squared, and we were to plug that in for a and b, we'd have 2 times 2x times 5. 2 times 2 is 4, times 5 would be 20x, which is what we have here. So if you can see a pattern like this, you can just go ahead right away and factor it into a 2x plus 5 squared. Now if you have the same pattern, but your first term is a subtraction, well that just factors into an a minus b squared. So if you have an x squared minus 6x plus 9, this is x squared, and the 9 is just 3 squared. And if you can see that this 3 and this x is a and b, and that fits into a minus 2ab, which it does, you'll get 6x, then you can just go ahead right away, if you see this pattern, and factor it into an x minus 3 squared. And that completes the tutorial on solving quadratics by factoring.